All right, guys, we're going to level up our game a little bit more with elimination. What if I have to change both of my equations now? Okay, so remember elimination, the goal is that we want to add or combine the two equations so that one of the variables is eliminated. That's why it's called elimination, right? So we're looking for zero pairs. So the first thing I ask myself is, do one of the variables already create a zero pair? If I look at my x's, I have 2x and 3x. That's not zero. I have 7y and 6y. That's not zero. Okay, so then I'm looking, can I easily multiply to create a zero pair? Well, 2 times something is not going to equal 3. 7 times something is not going to equal 6. Okay, so we have to do some work here to create the zero pair. Remember, zero pair means equal number but opposite signs. Okay, all right, so if we look at our x's here, if I want to change the x's, I have 2 and I have 3. So first thing I'm noticing is they're both positive, so I'm going to have to multiply one of them by a negative number. And I'm seeing like 2 and 3, that has 6 in common. So if I did 2 times negative 3, that would get me negative 6x. If I do 3 times positive 2, that would get me positive 6x. There's a zero pair. So I could go with the x's, okay? We could go with the y. We have 7 and we have 6, okay? And if you're not sure, you're like 7, 14, 21, 28, right? Like I could think of all of those pairs. If you know your multiplication, that might come to you a little bit quicker, right? I could do 7 times, and again, these are both positive, so one of them has to be multiplied by a negative because we need opposite signs, right? So if I do 7 times negative 6, that's going to give me negative 42y. And if I do 6 times 7, that's going to give me positive 42y. And there's your zero pair. Okay, so either way works. You just pick which one you want to use. So I'm going to go with the x's, just a smaller number to multiply by. So I'm going to use that one. I could totally change the y's and go that route as well. Okay. This time though, look, I have to multiply both equations by something in order to create the zero pair. So my first equation where it's 2x, I have to multiply the whole thing by negative 3. For the second one where it's 3x, I have to multiply everything in that equation times 2. Remember, you have to multiply everything so that you maintain equivalence. Okay, we can't just make up a whole new equation. We have to keep it equivalent, so it's still the same story. All right, so negative 3 times 2x is negative 6x. Negative 3 times 7y is negative 21y. Negative 3 times 13 is negative 39. Okay, so done with the first one. Then I do 2 times everything in the second one. So 2 times 3x is positive 6x. 2 times 6y is positive 12y. And 2 times 15 is positive 30. Okay, at this point, I have my zero pair. I can combine because I have that zero pair and I can eliminate my x values. Okay, so x is 0, and now we're going to add the equations together. So negative 21y plus 12y is going to be negative 9y equals negative 39 plus 30 is negative 9. And we need a positive 1 coefficient. So we divide by the coefficient of y to get it to positive 1. And negative 9 divided by negative 9 is 1 equals, and on the other side we get 1. So we think that our y coordinate will be 1. All right, so now that we have y, now we can plug that into either one of our equations and find our x value. So I'll just go ahead and plug in that first one. So 7x plus 2y, oh my gosh, 2x plus 7y equals 13. Now I can say it right. Wherever y is, we swap it out with 1, right? So we're going to take out that y. So 2x plus 7, parentheses for multiplication, times 1 equals 13. Okay, so 2x plus 7 equals 13. We want to isolate x, so let's zero out the constant. We get 2x equals 6 and make the coefficient 1. So x equals 3. So we think that our solution is the 0.31, right? That's what we think, and then you would do your check here. And so our check, you remember you plug in to both of our equations and it should make both of them true. So there's my x and my y, okay? So I would do 2 times 3 plus 7 times 1 equals 13. And then I simplify, right? So that's 6 plus 7. Hey, 13 equals 13 is true. So it works for one. We have to make sure it works in the other one. So 3x plus 6y equals 15. Again, plug in. So 3 times 3 plus 6 times 1 is the y value equals 15. Simplify, we get 9 plus 6 equals 15. Hey, that works out. So our solution is in fact 0.31. That would be the point of intersection. That's what makes both equations true. If this was a story, we'd be able to say what the x and the y represent, right? But that's elimination. Create a zero pair. Sometimes you got to do both equations. You got to change them both so that you create that zero pair. But that's always your goal. How can I create that zero pair? Do I need to multiply my equations by something to create that zero pair? Totally legit. Just make sure you multiply every part of the equation so that you maintain equivalence.